So this is worksheet 3, number 10. Let's see, vertical reflection. Yes, right, the negative sign there. Yes, amplitude is 3. Please be careful, the amplitude is not -3. On the test, there is a multiple choice question, and if it was this, one of the choices would be 3 and one would be -3. I know there's a -3 sitting there, and I know that flips it over, but the amplitude is still 3, because the amplitude is like how high is the wave. You don't say it's -3, you just say it's 3. So I'm trying to warn all of the classes, amplitude is 3, even if there's a negative there. Like if you want to kind of make a note to yourself that it's flipped, that's fine, but the amplitude is still 3. All right, phase shift would be right pi over 2. Vertical translation is up 2. And the period, see, the normal period for sine and cosine is 2 pi over b would be pi. Remember, when it comes to graphing these, I like to find A, B, C, D, and then use them in reverse. Use them D, C, B, A. So they didn't ask in the right order here, but vertical translation is up 2. Phase shift is right pi over 2. Oh, I need to be careful here, because I need to figure out like how far right do I want to go to put pi over 2, because my period is pi, so like I don't want to come way over here. I want to keep it, I guess, kind of close, because I want to be able to get one period in there and fit it on the graph. So there's 3 pi over 2. Okay, so there's my new origin, up to right pi over 2. There's my start over point, my other new origin, if you want to call it that. I guess they're all the start over points. Cosine, there's my little parent function graph. You don't have to draw that. I almost always do draw it. It kind of gets my brain thinking about cosine. And for me, it's hard to do all the transformations without looking at the parent function, but you don't have to draw that. So normally I start at a maximum, but this has been flipped over, so I'm going to start at a minimum, which means I'll start over at a minimum. And halfway in between, I'll be at a maximum. And halfway in between there, I'll be at the 0. Again, try not to do connect the dots where it's just a giant V. To help with that, you can think about concave up, concave down. That helps you put a curve on there.
I'm trying to put that -1.
So how did I know? Was it just down in general, or how did I know how far down to go? Amplitude is 3, so I needed to go down 3. And then up 3 on the other side there. So that made me have a max of 5 and a minimum of -1. Sketch at least 2 periods. Again, that's our kind of default, unless it says otherwise. We want to sketch 2 periods. You can go forward or backwards. Obviously on this one, we're going forward. Not really an option. So I need to go backwards pi. So that would put me right there at negative pi over 2. So that would be another minimum. A maximum would be right there. Halfway in between are the zeros. And again, as long as if you're thinking concave up and concave down while you're drawing it, you'll probably get the curves right, rather than just trying to connect the dots. So we go concave down, concave up. Maximum value of G, well, it got up to 5, and it got down to -1. Other questions on number 10? So number 12, secant. Before I get into the details, I'm thinking I'm going to graph a cosine, and then I'll do asymptotes and U's. And that's how I graph a secant. You don't really graph a secant. You just graph a cosine, and then put on the asymptotes and U's. Cosine looks like that. All right, so that's like big picture things. Now let's jump into the details. No vertical reflection because it's not negative. What about the vertical dilation factor? Sounds fancy. What is it for this one? 1. Like you could say there's none. There is no dilation. That might be okay. 1 would probably be the better answer. Phase shift would be left pi over 2. Vertical translation is down 1. And period is 2 pi divided by 1/2. So 4 pi. Okay, I don't like it when they ask these things out of order. A, B, C, D. D is down 1. So again, when you graph them in reverse. I'm trying to think how far down do I want to go. So my amplitude is 1, so I can go down pretty far because I'm only going 1 up and 1 down from the midline. So there's my midline. Next I'll use the phase shift, which is left pi over 2. But again, I got to think like how far left do I want to put pi over 2 when my period is 4 pi. Oh, that's a big period. So I don't want to go left pi over 2 very far because then I'll never be able to get 4 pi away from that. So I'm going to have it tucked in kind of close here. So there's negative pi over 2, which means there's my new origin. And I need to get 4 pi away from negative pi over 2. So let's see, negative pi over 2 plus 8 pi over 2 would get me to 7 pi over 2. So I need to put 7 pi over 2 out there so I know like where my graph fits. So 1, 2, 3, 4, 5, 6, 7 pi over 2. And I'm going to put a little crosshairs there too because that's my start over point. So I need to fit my graph in between negative pi over 2 and 7 pi over 2. Let's see. So I took care of the D, took care of the C, took care of the B. That's period. Amplitude is 1. So now I'm ready to start graphing cosine. I start at a maximum. I end at a maximum. Halfway in between is a minimum. Oh, halfway between -1 and 7 would be 4 marks away, so that'd be 3 pi over 2. There's my minimum. And then halfway in between those, I'm at 0. And as always with cosine, it's just tempting to just like connect the dots. But instead we're thinking concave down, concave up, concave down. Okay, that's my graph of cosine. I'm going to check all my properties real quick. Vertical dilation of 1, left pi over 2, that's a period of 4 pi, and it's down 1. So I feel good about my picture there. Sketch 2 periods. Okay, well that's only one, so I need to sketch one more. I can either copy paste forward, although I'd run out of room, so I'm going to copy paste backwards. So I need to go backwards another 4 pi, which would put me at negative 9 pi. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's another origin, another start over point. Starts at a max. Halfway in between, we're at a min. Let's see, that's negative 5 pi over 2. And if all your marks are right, you don't have to label them all. Halfway in between there, 0. Halfway in between there, 0. Concave down, concave up, concave down. And that's my cosine graph, but don't forget the whole point of this was secant. So I need asymptotes and u's on here. So asymptotes happen at the zeros. Zeros meaning like midline, not necessarily the zero, the actual x-axis. And then u's off the top and bottom. And I color-coded mine, but you don't have to do that. Like if you do it all one color, you don't even have to label. I know which one is cosine and which one is secant. Some people like the colors. Some people dash one or dot one or color or label it, whatever. You can if you want, if that helps you keep it straight, but it's not necessary. Okay, not done yet because give an equation representing all the asymptotes. Since we have the picture there, I think the easiest thing to do would be like just list the asymptotes and then figure out an equation that would cover all of them. So negative 7 pi over 2, negative 3 pi over 2, pi over 2, 5 pi over 2. So x equals, you can start with any of them, so pi over 2 seems like an easy one to start with. And then how far apart are they? How far apart are each of those? 2 pi. That's fine, that's good, that's accurate. I asked that question last period, and the student, I guess, was looking at numerators and denominators. He said they were 4 pi over 2 apart, which is correct. And so he put 4 pi over 2 times k, which would be fine. 2 pi k is maybe a little bit cleaner answer, but that would work. Let me show you how I work this problem, or because there's one on the test like this. I did the test last night, and I did it this way. I said, my thought was the asymptotes happen where the cosine is equal to 0. You can debate whose method is better. I don't like my method after watching students do it this way. But if I didn't have a picture, maybe this would be a better way to go. Asymptotes happen where the cosine is 0, because you'd be dividing by 0, and that doesn't work. So that means, well, forget the inside, that's complicated. Where is the cosine equal to 0? Let's think about unit circle stuff here. So that happens at pi over 2. And every pi after that. So wherever that argument is pi over 2 plus k pi, there's going to be an asymptote. Now this looks ugly, but it's not too bad. I'm going to multiply through by 2. There's the 2k pi, so that's looking good. And if I subtract pi over 2, I get the same thing. So this method is more of something a math teacher would do. It's not wrong. This method is something more of a student would do. Also not wrong. More intuitive that way, to do it that way. If you didn't have a picture, you might be forced to go this route, though. But we got the same thing either way. All right, that was a good question. I definitely wanted to work one that had the reciprocal stuff on it. Mainly, or partly because the answer choice isn't there, partly because there's one on the test similar to this, partly because I don't want to have to graph the whole thing to answer this question. So here's my function. What's the range? Okay. So I'm going to go down 1. My amplitude is 3. So that means I'll be going up 3 and down 3. And that'll be where the sine wave is in between -4 and 2. But that means the cosecant will be u's off of 2 and off of -4. So I'm not graphing the whole thing because I don't care about the left-right period stuff. Range is the y stuff. So I know my sine graph will be between -2 and 4. And so the cosecant will be greater than 2 and less than -4. So -infinity to -4 and 2 to infinity. Why do you think I want to work number 1?
It says 2x.
That 2x in there. So that doesn't look right. I need that 2 to be out front of the parentheses in order to get my phase shift right. So what needs to go in there so that if I multiplied by 2, I would get to pi over 2? Pi over 4. So I've got to factor out a 2. Even though it feels like there's not a 2 to factor out, I've got to get that 2 off of the x so that I can get my phase shift. So let's see. What's the amplitude of this graph? 3. Good. Not -3. Although it is flipped. The period is 2 pi over 2, so that would be pi. The phase shift is now left pi over 4. And we're going to go down 2. And probably straightforward after that, but that factoring the 2 out is the tricky part of that. Alright, so I guess I'll graph one more. So ABCD, DCBA, down 2. Left pi over 4. It's nice when the grid is given, that way you don't have to worry about like how far over should I make pi over 4. Period is pi, so that would be pi away is at 3 pi over 4. And sine wave looks like that. Again, you don't have to graph the parent function, but I think it's helpful. So I know my picture is going to look like that. Sine starts on the midline and ends on the midline, and in the middle is on the midline. I guess the danger of drawing my parent function is that I better be careful to make sure I account for the negative sign. So instead of going up to a maximum, I'm going to go down to a minimum, and then up to a maximum. So there's my first cycle of that sine wave. I want to graph 2 cycles, so I need to copy paste forward or copy paste backwards, either one. So pi away would put me here. So there it is, extended forward, extended backwards if you want to. Also, you don't have to necessarily do the copy paste thing, you can kind of just follow the pattern. Maximum, 0, minimum, 0, maximum, just keep going as long as you like. Just go all out, graph the whole thing. Again, all I'm looking for though is 2 cycles. So any 2 cycles you want to graph. Don't have to highlight the original. That kind of helps my brain to highlight the original, but you don't have to. It also, a little behind the scenes here, it helps me when I'm grading because I'll highlight my original. That way I know everyone should have that. I'll check that on your graph, and then I'll look at either ahead or backwards on your graph after that. Let me put it on video. Number 2 and number 6 are wrong on worksheet 4. The graph is wrong on number 2. We find all the information right, and then we graph it wrong, which is a fairly common mistake. It's frustrating to grade your papers because the mistakes will happen. Like almost everyone will get all the information right all the time, and then somehow it doesn't translate to the graph. In fact, I didn't do what I'd like to tell you guys to do. After you graph it, check and make sure it does all the things you said it would do. Down to, because it's easy to check these, left pi over 4, yep. Period of pi, yep. And amplitude is 3, yep. So I feel pretty good about that graph. If the person who made the key had done that little check on number 2, they would have figured out that they graphed the period wrong.
So the key is wrong?
The key is wrong.
Okay.
The picture is wrong. All the information is correct, and then they put it on the graph wrong. And then number 6 is wrong as well. Although 6 is pretty easy. That was just a dumb mistake on the key. 6 is not a hard problem. Okay, so you've got the rest of today to work on worksheet 3 or 4. Tomorrow there won't be any new assignment. We'll just work on worksheet 4 plus some warm-ups. So you probably shouldn't have any homework tomorrow night for sure. You might not have any tonight if you really work hard. And then on block day we'll get into some new stuff.